Ever wondered how your computer knows exactly where to send that hilarious cat video you just clicked on? Well, it's not magic, it's networking. And at the heart of this process are some intriguing little things called IP addresses. Picture this. You're at home, ready to send a letter to a friend across the country. You write the letter, put it in an envelope, and then you write your friend's address on it. Without that address, your letter wouldn't know where to go. It could end up anywhere, from your neighbor's house to a post office in the middle of nowhere. In the world of the internet, IP addresses are like those postal addresses. They are unique identifiers that help guide information from one place to another. When you click on that cat video, your computer doesn't just send it into the void and hope it lands in the right spot. It uses the IP address to know exactly where to send it. But what exactly is an IP address? The term stands for Internet Protocol Address. It's a set of numbers assigned to each device participating in a network that uses the Internet Protocol for communication. This could be your laptop, your mobile phone, your smart TV, or even your smart fridge. Each device has its own unique IP address, just like how each house on a street has its own unique number. Why are IP addresses essential? Well, without them, the internet as we know it would not exist. The web is a vast, interconnected network of devices, all communicating and sharing information. Without a system to identify and locate each device, this communication would be impossible. So when you're streaming your favorite show, sending an email, or laughing at cat videos, remember the humble IP address. It's working tirelessly behind the scenes, ensuring that your data gets to where it needs to go. So in essence, an IP address is a unique identifier for devices in the vast landscape of the internet. Did you know there are different types of IP addresses? Yes, indeed. It's not just a random string of numbers and dots. Let's dive into this intriguing world. First off, we have public and private IP addresses. Public IP addresses are unique across the entire web, just like your postal address. They help the internet find your device amongst billions of others. On the other hand, private IP addresses are used within private networks, such as your home or office. These addresses can be duplicated across different networks, similar to how multiple houses in different cities can have the same street address. Now, let's talk about IPv4 and IPv6. IPv4, which stands for Internet Protocol version 4, has been around since the dawn of the internet. It uses a 32-bit address space, which allows for over 4 billion unique addresses. Sounds like a lot, right? Well, given the explosive growth of devices, we're running out of these addresses, hence the birth of IPv6 or Internet Protocol version 6. IPv6 uses a whopping 128-bit address space. That's a theoretical limit of over 340 undecillion addresses. Yes, undecillion, that's a real number. This massive upgrade ensures we won't run out of IP addresses anytime soon. This transition from IPv4 to IPv6 is a significant shift in the digital world. It's like moving from a small town to a metropolis. This change has implications on the scalability of the internet, security, and even how data is routed. It's a complex process, but a necessary one to keep up with our ever-growing digital landscape. In conclusion, each type of IP address, be it public or private, IPv4 or IPv6, plays a pivotal role in our internet connectivity. They're like the unsung heroes working behind the scenes, ensuring we can binge watch our favorite shows, scroll through endless social media feeds, and yes, even work from home. So, whether it's public or private, IPv4 or IPv6, each IP address plays a crucial role in our internet connectivity. Now that you know what an IP address is, you might be wondering how it works. Well, let's dive right in and unravel that mystery. Think of an IP address as a unique identifier, much like the postal address of your home. When you want to send a letter to a friend, you write their address on the envelope. Similarly, when you want to send or receive data over the internet, your device uses IP addresses to pinpoint the exact location of the source and destination. So, let's say you want to visit a website. Your device breaks down the information you need into smaller, manageable pieces called data packets. Each of these packets is tagged with the IP address of your device, the sender, and the IP address of the website server, the receiver. These packets then travel across the vast network of the internet, hopping from one router to another until they reach their destination. But how does your device get its unique IP address? Enter the Internet Service Provider, or ISP. Each time you connect to the internet, your ISP assigns an IP address to your device. This IP address is like your device's passport, allowing it to communicate with other devices and servers across the globe. Your ISP maintains a pool of IP addresses and distributes them as needed. When you disconnect from the internet, your IP address goes back into the pool, ready to be assigned to another user. This process is seamless and happens in the background without you even noticing. But what happens when the data packets reach their destination? The server, recognizing its own IP address on the packets, accepts them. It then reassembles the packets into the original data, whether it's a web page, a video, or an email. And voila! The information you requested is displayed on your device. And that's how your device communicates with the rest of the world. One IP address at a time. It's a fascinating dance of numbers and data, all happening in the blink of an eye. So the next time you browse the internet, remember, there's a whole lot happening behind the scenes, all thanks to IP addresses. Have you heard about dynamic and static IP addresses? Well, let's dive right in. These two types represent the primary categories of IP addresses that are used across the internet. Dynamic IP addresses, as the name suggests, are dynamic in nature. This means they can change every time your device connects to the internet. Dynamic IP addresses are assigned by the network when your device connects and are returned back to the address pool when your device disconnects. This fluidity allows for efficient use of limited IP address space. Most of us in our homes, offices, or on our mobile devices are likely using dynamic IP addresses right now. On the other hand, static IP addresses are the opposite. They're fixed, meaning the address remains the same every time a device connects to the internet. Typically, static IP addresses are used for servers or network devices that require a consistent address for the sake of reliability. Your favorite online gaming server or the website you frequent might just be using a static IP address. Each type of IP address comes with its own set of advantages. Dynamic IP addresses are cost-effective and require less management. They're ideal for general internet users who don't need a permanent address. Static IP addresses, while more expensive and needing careful management, offer increased reliability and are crucial for certain internet services. So why might someone prefer one over the other? Well, it all boils down to their specific needs. If you're running a server or a remote access service, a static IP might be the way to go. But for the average internet user, a dynamic IP address is more than sufficient. In a nutshell, dynamic and static IP addresses are like leasing versus owning a car. With dynamic IP addresses, you get a different car every time you drive. While with static IP addresses, you get to drive the same car every time. Whether dynamic or static, each IP address type has its own unique advantages. And understanding these differences can help you make the most of your internet experience. So, let's sum up what we've learned about IP addresses. Our journey into the realm of IP addresses has been quite a revelation, hasn't it? We've uncovered some of the most intricate aspects of this cornerstone of internet connectivity. Starting with the basics, we explored the essence of an IP address. It's a unique identifier, a numerical label assigned to each device participating in a network that uses the Internet Protocol for communication. It's like the street address for your device in the vast city of the internet. We then delved into the different types of IP addresses. Remember the IPv4 and IPv6? IPv4, with its 4 sets of numbers, is the most commonly used. But as the internet expands, we're gradually shifting towards the more complex IPv6, with its 8 sets of alphanumeric characters, offering a virtually limitless pool of addresses. As we moved forward, we unraveled how IP addresses work. They form the basis of routing in the internet, directing data packets to their correct destinations. It's a bit like a postman delivering mail, but in this case, the mail is the data, and the postman is the Internet Protocol. And finally, we compared dynamic and static IP addresses. Dynamic IP addresses change every time a device connects to the internet, offering flexibility and ease of management. On the other hand, static IP addresses remain constant, providing reliable remote access but requiring manual configuration. So you see, these seemingly random numbers play a vital role in our digital lives. They help us navigate the endless expanse of the internet, allowing our devices to communicate and exchange information seamlessly. Next time you connect to the internet, remember the crucial role your IP address plays in making that possible. Keep exploring and stay curious.